Hello everyone, welcome to my next lecture. So in this lecture video I am going to explain what is electric dipole moment. Then ultimately I am going to derive an expression for electric field at an axial point of a dipole, and along with that I am going to derive an electric field at a point on the equatorial plane of a dipole. Okay, so first of all, what is electric dipole? Okay, electric dipole is a pair of equal and opposite charges separated by small distance. So that small distance we consider as 2a. Equal in magnitude means like 1 coulomb 1 coulomb, 2 coulomb 2 coulomb, 3 coulomb 3 coulomb, like that, but opposite in polarity. This one is positive charge and this one is negative charge. So equal and opposite charges separated by small distance. And its definition is like this: a pair of equal and opposite charges separated by a small distance is called electric dipole. And the examples are water, ammonia, HCl, and carbon monoxide, etc. Okay, so then we have electric dipole moment. What is this? See, magnitude of electric dipole moment can be written like this: P is equal to Q into 2A. Simple. And it is defined as the dipole moment of an electric dipole moment of an electric dipole is a vector whose magnitude is equal to the product of magnitude of either charge, any one of the charge you have to consider, product of either charge, and the distance between them. The distance between them is 2a. Okay, simple. And we have one more point here, that is the direction is from negative charge to positive charge along the line joining the two charges. Okay, so here dipole moment, you can see here in this diagram, this P is the thing but dipole moment, and which is directed from minus Q to plus Q. Why? That I will explain in the next video. Okay, so then I am going to derive an expression for electric field at an axial point on a dipole. Okay, so next concept is that. So here we have a dipole. Two charges are separated by 2a. So one charge is here. Let's consider this one is negative charge and this one is positive charge. If it is so, obviously dipole moment will be directed from minus q to plus q. Okay, so we need to find out the electric field at an axial point. That means the point on the axis of this electric dipole. So I am considering that point here, so along its axis. Okay, so let us consider the distance. So which distance I have to consider? Should I consider from plus q to p or minus q to p? So let us consider from the center. So r is the distance of this point P from the center of the dipole. So now what I have to do? So this can be found. The electric field at any general point P is obtained by adding electric fields due to minus Q charge and plus Q charge. And we have to add them. So by using what is that? A superposition principle, we can find the final answer. Okay, first the electric field due to plus Q charge is given by E plus Q is equal to 1 over 4 pi epsilon naught Q divided by R. So R square, that is the general formula that we have already learnt. So which distance I have to consider? Since the electric field is due to plus Q charge at this particular point, so means I have to consider this distance. So this distance will be how much? So that will be R minus A, because the distance from here to here is A. Okay na? So this complete distance is R. We don't want this much, we want this much. Means this one R minus A will give you this much. So this will be R minus A. So here we will get R minus A whole square. And if I write this one in vector form, I will write P cap here. So then electric field due to minus q charge is written as 1 over 4 pi epsilon naught q. This is negative charge minus q divided by r plus a whole square. So now we got the electric field due to positive charge at this particular point P and negative charge at this particular point P. So now what we have to do, we have to find the resultant electric field due to both the charges at this particular point. So how can you do that? So here I missed to put P cap. Yeah. So this is in vector form. So hence the resultant electric field at point P is E is equal to E plus Q and E minus Q. That means electric field due to plus Q and electric field due to minus Q. Okay, so then E is equal to, this is a resultant electric field, that is equal to 1 divided by 4 pi epsilon naught Q divided by R minus A whole square into pk plus E minus, that is 1 over 4 pi epsilon naught minus Q is there divided by R plus A whole square into pk. Okay, so then E is equal to, here 1 by 4 pi epsilon naught into Q, 1 by 4 pi epsilon naught into Q are constants, so I will take them out. Q divided by 4 pi epsilon naught, here we will be having 1 over R minus A whole square. Here plus into minus is minus 1 divided by R plus A whole square into P cap will be common. Okay, so then let us solve this. E is equal to Q divided by 4 pi epsilon naught. So if we take LCM for this, we will get R plus A whole square minus this one R minus A whole square divided by, you will get R minus A whole square into R plus A whole square, R minus A whole square into R plus A whole square. So into P cap, simple mathematics. So if we have a good grip on mathematics, you can easily solve this. So E is equal to same Q divided by 4 pi epsilon naught. So here A plus B whole square is R square plus A square plus 2A, sorry, in place of A we have R, in place of B we have A. Okay, so R square plus A square plus 2RA minus R square plus A square minus 2RA, because it is R minus A whole square, that is in the form of A minus B whole square. Okay, so divided by, here we have R minus A whole square into R plus A whole square. So I can write that one like this, R minus A into R minus A first term, then second term R plus A into R plus A. Okay, so R plus A into R plus A is R plus A whole square, R minus A into R minus A is R minus A whole square. So here R square minus R square, A square minus into plus minus A square will cancel out. So minus into minus will be plus. So this 2RA will get add up with this 2RA. Okay, then you will get E is equal to, into P cap will be there, Q divided by 4 pi epsilon naught 2RA plus 2RA is 4RA divided by, here we have R minus A into R plus A, that is in the form of A minus B into A plus B, that can be written as R square minus A square. Then again R minus A into R plus A is again R square minus A square. So we will be having two terms. If you multiply that, you will get this into P cap. Look at this, we have Q here, A here. This can be written like this: Q into 2 into 2 into R into A. Why? I will tell you why. So here I will separate this Q. Here I will take 2 out into A into 2R as it is. Okay, divided by 4 pi epsilon naught R square minus A square whole square. Okay, so if you multiply this, you will get the same thing. Okay, then E will be equal to this Q into 2A is nothing but dipole moment that we have already studied, P into 2R. Here we will be having P cap. So 2R divided by 4 pi epsilon naught R square minus A square whole square. Okay, so here 2AQ is nothing but P, that is dipole moment, that I have written here. So finally we will be having E is equal to into P cap, sorry. So E is equal to 1 over 4 pi epsilon naught 2 PR divided by R square minus A square whole square into P cap. This is the expression for electric field at a point on the axis of a dipole, or electric field at an axial point of a dipole. So this is all about this. Okay, so this is the final answer. So next we have electric field at a point on the equatorial plane of a dipole. So in the previous case we have found the electric field along the axis of the dipole, but here we are finding the electric field at the equatorial plane of a dipole. So I will consider a point on this dipole here, which is exactly perpendicular to this dipole. So I will consider this distance as R. So electric field at this particular point we need to find out. Let's consider this point is P, which is at a distance R from the dipole, from the center of the dipole. Okay, this is center O. So the distance between these two charges is 2A, means this distance is A and this distance is A again. Okay, now electric field due to a positive charge will be always radially outwards. So that is the basic thing that everyone should know. So if I draw a electric field line here, that will be in this particular direction, that is E. Okay, and electric field due to the positive charge will be towards it. Electric field line will be directed radially towards the negative charge. Then the resultant electric field will be in this particular direction. So this is electric field due to the positive charge. This one is electric field due to the negative charge, that is E minus, and this one is the resultant electric field. Now what I will do, I will consider this triangle, and in this triangle this angle is theta, means this angle also will be theta. So if this one is theta, this will be theta, and here also this will be theta. Okay, now electric field due to positive charge is given by plus Q is equal to 1 by 4 pi epsilon naught Q divided by this distance square. So this distance can be found by using Pythagoras theorem, that is a square plus x square under root. If I consider this as a right angle triangle, this side will be base square into perpendicular square under the root, and this distance also same, square root of this distance is a square, this distance is r square, sorry, this one is r. Okay, so now we will be having 1 over 4 pi epsilon naught, okay, q plus q divided by this square, that is a square plus r square under the root whole square. Okay, so then this will be directed in this particular direction. Okay, then e minus q is given by 1 over 4 pi epsilon naught q divided by square root of a square plus r square whole square. These two are the magnitudes of electric fields along this direction and this direction. If they are exactly opposite to each other, we can write minus sign here. Since they are directed in a particular directions, so we will find out the electric what is this resultant electric field due to both of them, then we can consider the polarity with respect to this dipole moment. Okay, so here the resultant electric field is given by the total electric field E is given by, and also remember this E is opposite to P, opposite to P. If we consider P, we will get minus sign in E. Okay, so then E is given by minus, I will tell you why, E minus Q cos theta plus E plus Q cos theta into P cap. First of all, I will explain why we got minus in here. Since electric field E vector is opposite to P, that's why we are getting minus in here. And cos theta is because the electric field due to positive charge along this axis is given by the component of electric field due to positive charge is given by EQ cos theta, and electric field due to this minus charge is E minus Q cos theta. So when you add them, you will get this. But along this direction, the electric field due to positive charge will get cancelled with the electric field due to negative charge. So we are not considering them. So that's why we'll get this. We have to consider cos theta. So here, what is cos theta? Cos theta is equal to adjacent by hypotenuse. So here only I will write cos theta is equal to adjacent is A. This side also you can consider for this triangle. So for this triangle, cos theta is equal to adjacent A divided by hypotenuse, that is square root of A square plus R square, because this distance is R. Okay, so now let us substitute all the values that we have here. So E is equal to minus, as it is, E minus Q is what? E minus Q is 1 by 4 pi epsilon naught Q divided by square root of A square plus R square whole square. Here A square plus R square under the root will get cancelled with this square. Okay, so we'll be having A square minus A square plus R square. Okay, so here 1 over 4 pi epsilon naught Q divided by A square plus R square, A square plus R square, plus E plus Q into, we have cos theta, that is A divided by square root of A square plus R square, plus E plus Q. E plus Q is what? 1 over 4 pi epsilon naught Q divided by A square plus R square, because here also square root will get cancelled with square. Okay, so we will be having 1 over 4 pi epsilon naught q divided by a square plus r square into cos theta, that is a divided by square root of a square plus r square. Okay, so then we have this, that is E is equal to, okay, into p cap, that is must and should, E is equal to minus, we have 2 times of the same terms, so we can write like this, 2 times 1 over 4 pi epsilon naught q into a divided by a square plus r square into a square plus r square, square root means power of, okay, into p cap. Can we write like this? Of course we can write like this. We have 2 times of the same terms. So here if you simplify this, you will get minus 2 1 over 4 pi epsilon naught, here only I will write this qa into 1 divided by a square plus r square, here we will be having power 1, 1 plus half is 3 by 2 into p cap. Here we know 2aq is nothing but a dipole moment. Okay, so we can write that here E is equal to p divided by 4 pi epsilon naught 1 over a square plus r square power 3 divided by 2 into p cap. Okay, so this is the expression for electric field due to a dipole at a point on the equatorial plane of a dipole. Okay, and here electric field is opposite to p, so that's why we will be having minus in here. Okay, so this is all about this video. We'll meet you in the next video. Till then, take care. Bye bye.